The Solax X3 electro-vehicle charger, meaning the Solax Wallbox. How to connect it properly, what you need to pay attention to, what it can do, and maybe what it can't do, as well as bidirectional charging and future technologies. That's what today's episode is all about. A warm welcome to another video on this YouTube channel. This Wallbox has actually been around for quite a while now. Nevertheless, I still receive problems and countless related questions about it almost every day. But not because the Wallbox is bad or doesn't work properly, but in 99% of cases, people simply haven't bothered to read the included manual. And that's why it's very often not connected correctly, especially when it comes to data communication with the inverter. And even more often, it simply incorrectly sets settings that are to blame for the operating modes which actually make this Wallbox stand out, and which we will discuss in detail today, not working as they should. I would really ask you today to watch this video all the way to the end. The longer you stick with it, the more interesting the information will get. If you don't have enough time right now, watch this instead of your usual evening program. There's only nonsense on TV anyway. Everyone who watches this video to the end will really know their way around this Wallbox, and everyone will also know how to install it correctly. I will also address a few changes that I have noticed in the slightly revised version of this Wallbox, which will be released in the coming weeks. I will touch on the often discussed topic of automatic phase switching, whether the Wallbox can do it or not, and I will show you how I solved the problem of phase switching with a version of the Wallbox that definitely does not have this function. Furthermore, at the end of the video, I will discuss how, in my previously presented large-scale projects, I not only use crypto mining to finance and stabilize the microgrid, but also utilize electromobility within its capacity to both maximize short-term storage capacity and, as a positive side effect, keep the microgrid stable without having to regulate it through frequency adjustment in order to get the maximum benefit from the system. A method that would also help stabilize the public grid here in Europe. Because even at my home in Styria, I'm already running in island mode again, since on sunny days I get up to 250 volts at my outlets, and I'm worried about my electrical devices. Thanks to Ohm's law, shout out to all the grid operators out there, we're not just dealing with the problem of excessively high voltage. Anyone who has passed the first year of electrical engineering should know that if you increase the voltage while keeping the resistance constant, proportionally more current will flow. That means the power consumption of my electrical devices, my smart TV, vacuum cleaner, dishwasher, and computer doesn't increase linearly, but rather quadratically. Many of our electrical devices simply can't withstand that in the long run. If my concepts were implemented here in Europe, none of these problems would even exist. But as I've explained many times before, the point here isn't to actually make any positive changes, because the problems that really need to be solved are still considered too minor. They wait until everything finally and completely blows up, and then everyone looks utterly dumbfounded on television at 10 o'clock at night on Zip2, and a few so-called experts will then explain to us precisely what we're supposed to do when the transformer station, or rather the public power grid itself, truly and continually keeps failing because of excessive voltage. Still, it's worth watching the video all the way to the end again and share it with your friends. It will be exciting as always. Become a member of my channel and use the few seconds from the intro to scroll down, press the like button, subscribe to the channel, and activate the bell. I'm Alex. Let's go. In my very first and initial video presentation on the Solax electro vehicle charger, I meticulously described a rather adventurous and somewhat unconventional connection variant. The reason for this was that the firmware at the time simply wasn't mature yet, and the green or eco mode didn't work due to improper communication. According to the wiring method I presented in that earlier video, it worked. However, it still wasn't ideal because the power data wasn't displayed correctly in the Solax Cloud app, but Solax fixed the problem fairly quickly at the time. So, for now, just forget about the wiring method from that earlier video. For quite some time now, the Wallbox has been working perfectly, and all the initial little issues have been resolved through new firmware updates. All channel members don't need to worry about the firmware anyway, because they're always on the most sensible and up-to-date version. A quick word on my own behalf. That's all on that topic. The Wallbox is connected like any regular consumer device, usually three-phase on the grid side of a hybrid system. However, in that case, the Wallbox will not be supplied with power during a blackout. Alternatively, it can be connected on the consumer side of a backup power-capable installation so that the Wallbox is also operational during a power outage or an off-grid mode. In these cases, I recommend my customers install the Solax X3 APS box due to the higher power demand. You can find out the difference between an installation with or without an EPS box in a previous video. Connecting the Wallbox to the three phases in our household. This is done at the bottom of the Wallbox after we have pulled out this connection part downward. Overall, it's quite straightforward and self-explanatory, although at this point I would like to point out the first differences compared to the version that will be released soon. The connection of the three phases, the neutral conductor, and the grounding works the same way in all versions. Data communication with the inverter as well as with the CT clamps basically works the same way in all versions and should always, and this is important, be done via the network connector, that is, the RJ45 port on the Wallbox and not on the green terminal block located right next to it. The Wallbox communicates via Modbus A1 and B1 with the solar 6.3 hybrid inverter. And these pins are located at pin 4 and pin 5 on the RJ45 connector and only there. And this is the same for all versions. On the green terminal block next to it, Modbus A2 and B2 are present. These are not intended for communication with the inverter, even if it works in certain configurations. The green terminal block next to the RJ45 socket is intended for connecting a smart meter as an alternative to the CT clamps and also for the parallel installation of multiple Wallboxes. In this setup, multiple Wallboxes share the surplus in green or eco mode, respectively, or the primary Wallbox communicates how much charging power it is allowed to use to charge the vehicle. In this case, it is also possible to set a power ratio. This means that if there is a surplus of 15 key dollars, I can, for example, set it so that the two vehicles are not charged with the same power, but instead one is charged with 10 key dollars and the other with 5 key dollars. In general, I recommend enabling communication between the Wallbox and the inverter because this also takes the battery storage into account. If the measurement is done exclusively at the main connection point, or if the surplus is determined using CT clamps or the smart meter, then in both green and eco mode, the battery storage will be drained because regulation only occurs once electricity is drawn from the grid. And that only happens when the battery storage has nothing left to give. Because in this case, the inverter can't know that the Wallbox is a Wallbox and not a vacuum cleaner, which is generally allowed to use the battery storage. However, if the Wallbox communicates with the inverter, it identifies itself as such, which means that it will not only regulate when electricity is drawn from the grid, but also when it is drawn from the battery. Additionally, if the Wallbox communicates with the inverter, you can set whether you want to use the battery storage when charging the vehicle, or whether, even when the storage is full and the PV output is insufficient, the car should be charged from the grid in certain operating modes. An absolutely crucial point that is very often done incorrectly. If you connect the Wallbox to the inverter, as mentioned, this should be done via the RJ45 socket on the Wallbox. As previously explained, pin 4 and pin 5 are used for this, which are connected to pin 4 and pin 5 of the communication board on the inverter. You're naturally inclined to just plug in a network cable. However, you definitely should not connect all 8 pins, but only those that are needed for the specific communication. And when communicating with the inverter, that's only 2 pins. With the new version of the Wallbox, which is coming soon, the corresponding RJ45 connectors are included. A white one for communication with the inverter and a black one for the CT terminals. Only the correct pins are occupied in these. When using these adapters, you can then use an 8-core cable. With the current version, however, you should cut the cable yourself, or if you use a pre-made network cable, cut off the connector and put on a new one, but only connect pin 4 and pin 5. In some cases, it still works. However, problems often occur with a parallel installation. If you have a parallel error, that could be one of the reasons. And since we're already talking about parallel installation, you of course need to connect the data cable to the COM board of the master. In a so-called super smart photovoltaic forum, I recently read a statement saying that if you have this parallel error because of the Wallbox, you just need to connect the Wallbox to the slave. It's true, the parallel error will be gone, but it's basically the same as if you didn't connect the cable at all, because the slave doesn't provide the data relevant for the Wallbox on the COM board. Shout out to Lee Merrick, who could tell you a thing or two about this. Please ask me, and don't let yourselves get confused by the nonsense that's spread in some forums. That's all there is to say about that. Another essential point for the Wallbox to work properly is that when using the recommended communication with the inverter, you need to set a few specific parameters correctly, both on the Wallbox and in the advanced settings of the inverter. Specifically, you need to tell the inverter to communicate with the EV charger via Modbus, and you do this in the advanced settings of the Solax X3 hybrid inverter. The default password is 2014, and you'll find this under the Modbus menu item. And directly below that, you also need to set the baud rate, which in this case must be set to 9600. The address is preset to 70 by default, and the Wallbox is also configured with address 70. Another absolutely important point is that in a parallel installation, you must set the same baud rate for each individual slave in the Modbus menu. Why this is the case, I don't actually know myself, but if the settings are not identical, you'll get a parallel error. Back then, I once spent hours trying to find the cause of a parallel error in my own system. In the advanced settings of the Wallbox, you also have the option under the menu item Grid Data Source to specify whether the Wallbox should communicate via the CT clamps, a smart meter, or, as recommended, via Modbus with the inverter. However, this menu item should actually be set correctly automatically, but only if you have carried out the wiring for data communication as previously described. So in any case, it should now say inverter there. With the current version, you only have the option to connect the Wallbox to your home network, or rather to the Solax cloud via Wi-Fi. How to connect it is something I explain in a previous video called How I Install the Wi-Fi Dongle. With the Wallbox, it works exactly the same way. It generates a hotspot just like the dongle does. You connect to this, enter into a browser 198.162.10.10, log in as user admin, and use the registration number of the communication module as the password. You'll find this number on the left side of the nameplate. Then in the menu that appears, set up your home network and afterwards add the serial number in the Solax Cloud web portal. As always, the usual procedure, and that's it. With the new version of the Wallbox, in addition to the RJ45 port for data communication, you even have a LAN port, which allows you to connect the Wallbox directly to a router. In this case, you only need the serial number, which is the same as for the Wi-Fi communication, to add it in the web portal under System and Add Device. So that was basically the connection of the Solax X3 electric vehicle charger. Next, let's take a look at the functions, or rather the operating modes of the Wallbox, which are pretty much the same across all versions, except that the new versions have a few additional features, primarily concerning the locking of the Wallbox. The purpose of this is to prevent, for example, your neighbor from charging up his car with your electricity while you're on vacation. Unless, of course, you allow it, which basically also makes sense, because then the electricity is used that would otherwise be lost to the public grid. The most important features of the Wallbox logically include the two operating modes, which I will now briefly explain to you in a nutshell. First, we have the operating mode called Stop. Quick question. What does that mean? What happens in this mode? You guessed it right. Nothing happens at all. So if you have plugged in the vehicle and the Wallbox is in this mode, it is in a standby position and waits until another mode is activated. The next operating mode, which is quite easy to understand, is the fast or quick charge mode. In this mode, the Wallbox charges the vehicle with the charging current set at the bottom right. A lot of electric vehicles can only charge with a maximum of 16 amps per phase using alternating current anyway. That's about 11 kW. So it only makes sense to opt for the 22 amp Wallbox in exceptional cases. That would be 22 kW. There are actually only a few vehicles that can be charged with AC, that is, alternating current at 22 kW. All charging stations that can charge with higher power do so using direct current. Remember that. So, as soon as you activate fast mode, the vehicle will be charged at the set charging power, provided, of course, that the vehicle can actually accept that current. The electricity for charging the vehicle is drawn from wherever it is available, just like with any other consumer. This is primarily from the PV modules. If you allow it, then also from the battery storage. And if the energy from the PV system is not available or not sufficient, then this amount or the difference will be drawn from the public grid. Allowing the battery storage to be used for charging the vehicle can be set in the advanced settings of the inverter under the menu item Battery Charge EVC, where EVC stands for Electric Vehicle Charger. I think this mode should now be clear to everyone as well. Things get a bit more complicated in green mode or eco mode. With these operating modes, the charging power of the Wallbox is adjusted to match the currently available surplus. This information, how much surplus is currently available, is received in the recommended connection setup, let me clarify, by both the Wallbox and the inverter. Let's start with green mode. We need to keep the following in mind. The Wallbox can regulate its charging current in 1 ampere increments. The 11 kW Wallbox, that's 16 amperes per phase, can therefore charge the vehicle with a maximum of 11 kW. However, the Wallbox also has a minimum charging power, which is 6 amperes per phase. That's a little more than 4 kilo. This means that the Wallbox can charge the vehicle in 3 phases with a power between 4 and 11 kilowatts. With the green motor, it's the case that the vehicle only starts charging when the surplus is sufficient for the Wallbox to receive the start signal to charge at the minimum possible charging power, which is 4 kilojoules. And now it might get a bit confusing for some, because we can set at what level of surplus the Wallbox receives the start signal, and we can choose between 2 parameters. Specifically, start charging at 3 amps of surplus per phase, which is about 2 kW, or start charging at 6 amps per phase, which is a bit more than 4 kW. Let's say, for example, we tell the Wallbox to start charging when there is already a surplus of 2 kWh. The Wallbox will then start charging as soon as there is a surplus of 2 kW, and it will do so with the minimum possible charging power. But as mentioned, that minimum is actually 4 kW. So what happens now? Here's a question for you. The Wallbox has to get the missing 2 kilowatts from somewhere else, and that happens either from the public grid or, if we allow it, from the battery storage. But now, if we set it so that the Wallbox only receives the signal to start at 6 amps per phase, which is 4 kilowatts, it therefore makes sense that with this setting, nothing is drawn from the storage or from the grid. Because when the wall box receives the start signal, there is already as much surplus available as the minimum possible charging power. In this mode, the wall box then adjusts according to the available surplus, increasing or decreasing the power, and switches off completely when the sun goes down or when the surplus drops below the set power of 2 or 4 kilowatts. But that also means that depending on the setting, before the wall box switches off completely, up to 2 kilowatts can definitely be drawn from the grid or the battery, depending on whether you have set it to 2 or 4 kilowatts. However, you don't actually set 2 or 4 kilowatts, but as mentioned, 3 or 6 amperes. So when is this mode suitable? This mode is ideal, for example, if you don't urgently need the car over the weekend and you really only want to charge the car when you have surplus electricity, and if there is no surplus, then the vehicle should not be charged. The eco mode basically works similarly to the green mode. It also adjusts the surplus up and down accordingly, but with one difference. As soon as this mode is activated, the vehicle immediately starts charging and continues until it is full or has reached the set maximum charge level. The charging power that is utilized in this mode, which inherently means even when there is very little or virtually no surplus available, is precisely set within the dedicated settings for this particular mode. For example, if you set it to 6 amps, the vehicle will always charge with at least 4 kW, but it will ramp up if more surplus is available or ramp down again when the sun goes down. But it will also continue charging at 4 kW even then. Those were the operating modes of the wall box. One question I keep getting asked is, why doesn't the wall box continue charging with a single phase in green mode when the surplus drops below 4 kW? The answer is quite simple. The current version of the wall box cannot perform automatic phase switching. However, the version that will be released soon will be able to do this. The question is whether you really need that. Everyone has to answer that for themselves. In any case, with the new version, it is possible. It is also possible in the following way. At home, I have the current version installed, which can basically only charge on 3 phases. But the wall box doesn't care whether I actually draw power from all 3 phases. That means it always supplies power on all 3 phases. But if I only draw power from one phase, it still works. In fact, I can use the 3-phase wall box to charge a vehicle that can only be charged on a single phase. And because of this fact, I did the following. But this is not an invitation for anyone to simply copy what I did. I really want to make that absolutely clear, because under certain circumstances, you could lose your warranty if you do something wrong and the wall box or your car gets damaged. But here's how I solved it for myself. I got a charging cable extension so I wouldn't have to cut the original cable from the wall box. Instead, I used the extension and routed the 3 phases of the extension cable through a 3-phase Shelly Pro 3. Then, in Home Assistant, I set up an automation that when the surplus drops below 4 kW, first interrupts the charging process. That is, it switches the wall box to stop mode. And it's important that this whole process doesn't take place while charging is ongoing. With an appropriate time delay, I then have phases 2 and 3 switched off via the Shelly, and then I restart the wall box. But this time in fast mode, and I control the amperage using the corresponding charging power entity in Home Assistant. If the surplus then goes back above 4 kW, the whole process happens in reverse. Phases 2 and 3 are re-enabled after a short stop, and the wall box then continues to operate in green mode with automatic regulation. I implemented the whole thing at my place, not because I really need it, but because I was interested to see if it would work. I coordinated the whole thing with my colleagues in China. Basically, there's nothing against implementing it this way. But I don't actually need it. I have 35 kilowatt hours of electricity storage, and I also have no problem using it to charge the vehicle. The current version, as well as of course the new ones, also have a few more functions in the so-called boost settings. For example, you can set it so that if you urgently need the car at a certain time, it will be fully charged by then. You can also charge it quickly according to the schedule or time window. All these functions are self-explanatory when you have the Wallbox settings in front of you on your smartphone. However, what I find a bit unfortunate is that the Wallbox cannot do the following. I then implemented that myself using Home Assistant. It wasn't difficult at all. Specifically in Eco or Fast mode, you can only set by default whether the power should be drawn from the home battery when needed, that is, when the PV system isn't supplying enough or not. But unfortunately, you can't define that the vehicle may only discharge the home battery down to, say, 50%. Of course, you can limit the minimum SOC of the battery to 50%. But then, the same SOC minimum also applies to all your other consumers. Using Home Assistant, I created a function called Wallbox Auto Off at SOC. This means that when this function is enabled, the Wallbox will definitely switch off once the battery reaches the set SOC. That's pretty cool. For example, when I come home in the evening and the battery still has, say, 95%, I plug in the car in Eco or Fast mode, set it to charge at, say, 10 amps. Which already draws from the battery, and then I let it run until the battery reaches the set minimum, and then the Wallbox automatically switches to stop mode. I don't really want to say much more about the Wallbox now. Let's move on to the next topic, as I mentioned at the beginning. So, what else is possible? Because the technology is already there, unfortunately the politics aren't, but I don't really care about that. I'm implementing it in my off-grid systems, both on a large and small scale. And that is about bidirectional charging. That means not only sending electricity into the electric vehicle, but also getting it back out and using the vehicle as a power storage unit. Many people have already heard the following: vehicle to load, vehicle to home, vehicle to grid. But what does all of this actually mean? How does bidirectional charging work? What do we need for it? And what does a Wallbox that supports bidirectional charging do, as well as the new hypercharger from Solax, which has already been introduced but whose development is not yet 100% complete? First of all, before we take a look at the terms vehicle to load, vehicle to home, and so on, when it comes to bidirectional charging and discharging, we need to distinguish between AC and DC systems. So, on the one hand, there are systems that draw alternating current from the vehicle, and on the other hand, systems that tap direct current directly from the vehicle's battery. Most systems are AC systems, and this already leads to the first problems, because with this technology, the inverter installed in the vehicles is used. As we all know, the battery supplies direct current. The drive components of an electric vehicle, that is the electric motor, operate with alternating current, or in this case, three-phase current. With an AC system, there is no additional separate inverter located outside the vehicle. Instead, the Wallbox simply sends a precise command to the vehicle via a standardized communication method, effectively instructing the vehicle's internal inverter to supply electrical power to the Wallbox as and when it is needed. This streamlined process ensures efficient and reliable energy transfer. The Wallbox is then connected to our home power grid, and in this way, our household is supplied with electricity from the electric car. It's different with a DC system. As mentioned, direct current from the vehicle's battery is used to synchronize with our home grid via an external inverter. Such systems are already being developed by Solax. But as I said, all the systems I actually know of are AC systems. And now we've already arrived at the term vehicle to home. This refers to the ability of the vehicle to supply alternating current to our household via the Wallbox. For that reason, it also makes sense that two things are needed for this whole setup to work. On the one hand, you need a Wallbox that gives the command for defined charging or discharging, and on the other hand, a vehicle that not only understands these commands, but can also synchronize itself with the existing power grid. Every vehicle that supports this technology, namely vehicle to home, is characterized by the fact that the inverter in the vehicle has the ability to synchronize with an existing power grid. The problem, however, is that our grid operators also have to approve the inverters in the vehicles, and that's usually where the whole thing fails, because they're not even able to promptly approve a new Solax when it comes onto the market. But in my off-grid projects, the vehicle or vehicles synchronize with a power grid that is generated for me by the Solax X3 Ultra. And in that case, the grid operators can kiss my ass, because in off-grid mode, I do exactly what I want. If your vehicle only supports the vehicle-to-load function, that simply means that the vehicle usually also has 230-volt sockets where you can plug something in. The supreme discipline among all these technologies, which, as things currently stand, will probably never catch on here, is what's known as vehicle-to-grid. And this is exactly the technology that we are in the process of implementing in our large-scale projects, specifically in places where entire areas are supplied in island mode 365 days a year. In these cases, not only are the components necessary for power supply provided by the government, but e-mobility is also promoted accordingly. This means that incentives are definitely created through generous subsidies to purchase compatible electric vehicles, but owners must then also make them available as energy storage within the framework of an individually defined agreement. But what does this look like in practice? It's actually quite simple. Whenever the vehicle is not in use, it is connected to compatible charging stations. Through a special overarching control system, which originates from the root, namely the Solax X3 parallel installation, which in our case simulates the public grid whenever there is a surplus, and the miners who finance the whole system by generating unconfiscatable purchasing power are already running at full capacity. The system manages the process accordingly. The surplus electricity is automatically stored in all electric vehicles that are currently connected to the charging stations. And all of this, of course, is free of charge for the vehicle owners. However, in return, they must, as part of an individual agreement, make this electricity available to the public again when needed. In my opinion, this is absolutely brilliant. Electricity would be available to everyone for free. The whole thing is financed by the state, but instead of taking the money from its citizens, it is funded by the power of the sun itself. Our electric vehicles are always fully charged according to our needs because the system recognizes this through artificial intelligence or smart home applications. Already a reality on other continents, but in Europe it's still a long way off, except for my smaller off-grid projects. That means when it comes to bidirectional charging and grid parallel operation, you'll definitely have to be patient. No one can tell you how much longer this will take. The technology itself definitely already exists. But without cooperation from policymakers, the whole thing is only feasible to a limited extent, so only in off-grid operation. Thank you. Honestly, I can't talk anymore. Thanks to everyone who stuck with me until the end. I tried to give you a lot of information in this video, but without going too much into detail so as not to confuse you. All other functions not mentioned are self-explanatory and are also described in detail in the manuals. For detailed information and questions about the video or about the technologies about bidirectional charging, I am, as always, happy to help. Of course, questions from my channel members are answered even faster and in more detail. Not only I, but also the YouTube algorithm would appreciate a like or a comment. And we'll see each other again in the next video.